functions. Which is conditional logic, when and otherwise. Okay, so in when and otherwise we can see the different conditions, like when. So to use a when in PySpark, it is equivalent to case when or if then else with the SQL. It evaluates a Boolean condition for each row and return the corresponding value. Multiple when calls and call can be chained for multi-branch logic and otherwise provide the default fallback, like the else condition in the SQL. So to implement this case and when, we'll see the different approaches. So first approach would be like single branching. Okay, so in the single branching, let's see how it can be implemented. So we'll see the step-by-step approach. Let's see the how tables looks like when we use a single branching. Let me show you here. Okay, in a single branching, let's say we have the row data. Okay, in which name is mentioned, which is the name Alice, Bob, Carol, and Dave, and their score. So we can provide the condition if score is greater than equal to 90, then it should return the Boolean value, whether it is a true or false, and corresponding result, whether it is a pass or fail. Okay, this can be derived from the Boolean conditions. Okay, we'll similarly implement this into the actual PySpark code. Okay, let's see how the single branch with the case when or when otherwise statement. Okay, let's create the data frame. I have prepared it already. So let's see the data frame using df.show command. Okay, there are many more commands to display the results. I am using a show command. Okay, we'll tell you the differences in the different sessions, which display, what type of display command we can use. So display and the show option, there is a number option truncate. Okay, we can pass it as a false or true value to the truncate. It is depend on the data sizes. Okay, we'll see this in detail later. So we do have the name and score field, in which name and score provide the 4 records each. Okay, so how the single branching work here? So let's try to select the column from the existing data frame. Let's type a df dot select. In select, we'll select the columns. Okay, let's select the name, name, score. Now we have selected 2 columns. Let's use a single branching for the case when statement. So the condition here is if the score is greater than or equal to 19, we should return the result pass. Otherwise, we should return the result fail. Okay, we only have to derive the result column from here, which is this column. Only this column we have to derive based on this condition. Okay, let's try to write this function. So f dot when. So this is also function. That's why we have to utilize functions f dot when. Inside the functions, we have to again use the column functions. So column would be the score. If score is greater than or equal to 90, then what should it return? It should return the pass. Okay. So to what is the other condition? Otherwise condition. So we are continuing in the statement. So the otherwise statement will pass, make it as a fail. So if any case, if it is not greater than or equal to 19, then the candidate considered to be as a fail. So we'll alias it as a result or result. Okay, and let's try to display our data frame. So now there you go. So each score which is greater than 90 has a pass result, so other columns get the failed results. Okay, similarly, if you want to change this condition, if the marks is greater than the 60 or 65, then it should return the pass for 3 columns, 3 rows, and the fail for 1 records. Okay, so what happens if there is a null value in it? Okay, if there is a null value, result should be the null in that case. Okay, so to be precise to mention this, what is the condition? So it tries to validate the condition and then return the Boolean value. Okay, and Boolean expression. Okay, and once the Boolean is written, it will return the condition value. It will return the condition value. So in second case, this is the fallback mechanism. If it is not matched, the condition return the false. Then what is the results? Okay, then it will return the failed results in this case. Okay, so we have discussed how to implement the case when logic inside the PySpark. So this is the single branching when otherwise. So let's move to the multi-branching case when. So it's kind of a grade bucketing example. Okay, let's create this multi-branch when. Okay, so there can be the multiple, like we only added a one condition and the other condition. There can we add a multiple condition here with a different where logics. Okay, let's say take the same example. Okay, I will show you one table how we can implement for this one. So let's say this was the example one, this was the example two. Okay, how do you have a name score? Okay, there are the multiple conditions. If the score is greater than equal to 90, then it should return some result and then it should stop the following processes. If the score is greater than equal to 80, then it should return the result and stop the following process. But if it returns a false result, then it should go to validate the next condition, which is if it is greater than equal to 70, then it should return the result. Else, if it is not met, then move to the second condition. So based on that, we will grade the each student based on these values, which is greater than equal to 90, 80, 70, and 60. Okay, let's go back to the Databricks notebook and implement the same logic. So we will use the same data frame. So I would not create it again for you. I will show how data frame is look like. Okay, so try to implement the same logic. Okay, just copy this code and try to implement it. Okay, now we have the condition. I will remove this comment from here. Okay, and try to implement the logic here. So now first logic has been implemented, which is if the result is greater than equal to 90, then it should return the A. Okay, let's give the enter and try to implement the second logic, which is when dot when result is greater than equal to 80, then B, result is greater than equal to 70, result is C. If the result is greater than equal to D, then greater than equal to 60, then it should return the D. Now we have implemented the four condition now. So let me try to add a here. So condition, this one goes to 1, this second, this third, and this is the fourth condition. Okay, now we have implemented the four conditions here. Based on this condition, we categorize the grade. So this should return the if there is a no score has been given, we should return the unknown value here, and the result should be the name should be for this column. It is a grade. Okay, let's try to run this. So there you go. So if the result is greater than equal to 19, we should get a grade A. If the result is greater than equal to 70, then it should return C. Okay. If the result is greater than equal to 80, it should return a B. Or likewise, if it is a null, then it will return the unknown value there. Okay. So now we have learned about this thing. So there are the shortcuts. So Spark stop evaluating further branches as soon as condition is true. Place the most specific narrow condition first. Okay. So there I have mentioned in the table. So Spark try to validate this condition. If it founds it as a true, it stop processing other condition for the specific record. Okay. Similarly for other. So so there is another situations where we can do the conditional logic to handle the nulls. So try to implement that situation as well. So let's see when with the null handling combining with the is null. We'll see is null as well as the when for the null handling. So here let's take a data. If some data has a null value in it, I have prepared it for you. So let's see the data how it looks like. Okay, there you go. You can see Bob has a null score. Okay, how we can handle this null score? So if there is a value null, okay, we have implemented a unknown logic here. Okay, so in this case, what we can do? Okay, so if you run this same query on this data, it should return the null value. Okay, let's try to implement the same query on null value. So there you go. So data condition found the null value, it returns the unknown that we have implemented here. If it is not there, it will return the null there as well. Okay. So how we can handle this using is null. Okay. So for this we can add a either in otherwise we are not sure whether it is a string value, whether it is a non-numeric value. It can return unknown to any specific column or not specific column. Okay, so we should handle the null separately. So how we can handle? We can utilize the second option, which is null. So is null returns the boolean value whether this value is null or not. Okay, and then based on that we can take the decisions. Okay, let's see if I return this column score, we'll use the is null functions here. Okay, then if it is a null, then it should return the out of scope, like or we can mention it as a no score. Okay, so this way we can handle this null value. Now we should get the result as a no score of here. Okay, now we have specifically handled the null, and unknown will return the results for the unknown value, like if there are the spaces in it. Okay, let's try to create the similar kind of a data. Let's change the Carol record to the space. Okay, now now Carol does not have anything, but it is having a space here. Now in this case, again we will get the unknown value for that as well and for a null as well. But in this case, we will get the different outputs. For a null, since we have handled it separately, we'll get the no score. For that space, we will get the unknown value there. Okay, this is how we can use a when with is null combination to handle the nulls.